friends, and welcome to lesson 2 of area and perimeters of your math class. And what we're going to be learning about today is area, calculating the area of something, which we learned from our last lesson, means the surface area of a flat object, using square units. Now we're only going to do this for a little bit, only 2 lessons, just to learn how to calculate the area and what it means. And then we're going to use a very special formula that teaches us and tells us how to calculate the surface area of different shapes. Now, I want to talk a little bit about what a unit is. Now, a unit, as we learned from the chart of metrics, is basically a measurement. A millimeter, a centimeter, a kilometer, or sometimes we just call it a unit. You're going to see it several times throughout your exercise book, just the term unit, to measure or calculate a measurement or something. So a unit square is a square with each side measuring the same length. We're going to be seeing a lot of that as we start going through these next couple of lessons, so it's important that you know that term. Now, I want to talk about my squares here. Not all of my squares are perfectly accurate, but I want you to imagine that they are. I tried my very best on most of my squares to make them perfectly square squares, but I'm only human and I make errors. So here is a drawing of a square, and I want to talk about these little lines that you're going to see throughout this unit and what they mean. So this little line here, it means that all of the sides of that shape, or wherever that line is, means it's the same length. So you might see it in composite shapes, that one side has the same length as the other side with a little dash on it. So 1, 2, 3, 4 dashes means that all of the sides of this square are exactly the same length. On a rectangle, you might see a dash at the top and a dash at the bottom. And then on the other side, you might see 2 dashes. Whenever you see a symbol like this, that's the same on other sides, it lets us know that it's the same measurement, so that we don't have to write all over that measurement 2 centimeters, 2 centimeters, 2 centimeters, 2. It just gets boring. So we use a dash to save ourselves some work and to save us from having too complicated of a drawing to read. So I want to make sure that you write down that red, because that's important to remember. Keep that locked in your head. And if you just zoned out right now, rewind it, because you need to know about those dashes. All right, so how do we calculate the area of these shapes? How is it done? Well, let's take these 2 shapes, for instance. Now, we can see right away that these shapes have the same blocks, so they probably have the same area. So what we have to do first is we have to look at how many whole squares there are. Well, there are 1, 2, 3, 4. There are 4 whole squares, and they're giving us all the information, so all we have to do is write the number 4 there, and I've already written it for you. 4 whole squares is the surface area of this object. But I also want to talk about this little red circle I put around the term units. So at the end of every single area calculation, you have to write it down in how many units it is. Well, for this particular one, they haven't given us any kind of dimension or any kind of measurement. They haven't told us that it's centimeters, kilometers, or millimeters. So we just write the term units. Sometimes it'll just say the word unit beside it. But for this one, they haven't given us anything, so we just write the term units. And after the term units, we have to put a little 2 on the top. Why, you ask? Well, we are measuring a 2-dimensional object. So the 2 lets our reader of our math problem know that we just calculated a 2-dimensional object. So the surface area of this object, surface area, is 2-dimensional, and it's in units squared. Now, you might remember from last year, or you might remember from several years ago, talking about 3-dimensional objects. Now, 3-dimensional objects have a little bit of the same characteristic as 2-dimensional objects. We calculate their volume. Whoops, good thing I have another one right here. We calculate using a formula. And when we write a 3-dimensional object, when we write the units, because it's 3-dimensional, we use the number 3. But right now, we're worrying about 2-dimensional objects, so we don't even need to talk about the volume of 3-dimensional objects. We are just going to remember that every time we calculate a surface area through this whole unit, we're going to put a 2 at the end, because otherwise, I don't know what the heck you're talking about. Let's go on to this next one. Again, it has 1, 2, 3, 4 whole squares, so we write the number 4 here. And then we know that the area is equal to 4. Now, oh, look, they gave us a unit this time. They gave us millimeters. So we're going to write down millimeters squared. So our reader knows that the area of this object is 4 millimeters squared. Now, I know, my friends, that that object is not 2 millimeters. But you'll remember way back in our ratios and rates unit that we talked about scale drawings. For the purpose of exercising our brain and using different dimensions, we are using different units. And we are just imagining that this is 2 millimeters. Now, it'd be really hard to draw 2 millimeters on here and actually allow you to take the notes and see it properly. The same thing in your exercise books. When you see 1 millimeter or 2 millimeters, you're going to know that's not really 1 millimeter, but it's a scale of 1 millimeter so that we can practice exercising our brains for different metric units. Now, not all shapes are the same. Not all shapes are square. And as you work through your workbooklet, you're going to notice that some of the area calculations that you see are going to have squares and triangles. Now, to start off triangles at first, I want you to realize that this triangle and all the triangles that you'll be shading in your workbook represent half a square. So let's go ahead and calculate the area of this square. So the hints that the problem is giving me is that I have to determine the whole squares and the half squares to get the area of the entire shape. Well, let me take a look. There is 1. It's always a good idea as you're working through these problems to put a little X on the squares or the shapes that you've already counted so that you don't count them again. So I see 1 whole square and I see 1, 2 half squares, which are triangles, but half a square is either a triangle or a rectangle, and I see 2 of them. So 2 halves and 1 whole is going to equal to how many? It's going to equal to 2 in total, because these 2 halves make 1 whole square. So I know that I have 1 whole square and 2 half squares, which equals 2 full squares. Now let's look at our next unit. But before I do, I'm going to pause for a second because I want you to remember that we need to include the unit up there. Now, as you work through your workbooklet, you're going to see that the unit is going to be written in kind of obscure places, and you always have to pay attention to what unit you are working in. You have to pause and look at the shape and say, does it say millimeters, units, centimeters, hectometers, kilometers? Well, let's take a look at this one. This one right here has an M. And from our unit on ratios and rates, and from learning about the chart of metrics, we know that that M means meter. And we know that our units are in meters, so we have to add an M here. And like I talked about before, because we're calculating the surface area, and we want our reader to know that we are calculating the surface area of a 2-dimensional shape, we have to add a 2 at the top. So those who are reading our math know that we are calculating in meters squared. Let's look at our next shape here. Now I'm going to analyze my shape. I'm noticing that I have 1 whole square with 1, 2, 3, 4 lines, which tell me that all sides are the same, so I know it's a square. And it's showing me 2 little smaller units here. Now for the purpose of this workbooklet, we are going to know right away that that represents a quarter of a unit. So how many whole squares are there? There is 1 whole square, which is right here, and again I'm going to put an X so that I don't count it again. And how many quarter squares are there? 1 and 2. Now I know that 2 quarters make 1 half, so I know that my shape is equal to 1.5, or you can put 1 and a half with a half symbol like this. But I also need to see, okay, it's in units, 1.5 units. And like I said before, we need our reader to know, are you calculating the perimeter or the volume or the surface area? The surface area of a 2-dimensional shape is in units squared. Let's move on to some more complex shapes, because you're going to see quite a few complex shapes as you work through your exercise book. Now, not all the questions you are going to do are going to have all of that writing for you. Some of them are just going to have for you the word area, and you have to calculate it yourself. Okay, so what I'm going to do is I'm going to first count my whole shapes. I have 1 whole shape, and I'm going to put 1 plus, how many half shapes? I'm going to work my way down. 1, 2 plus, I might even go like this, 1 whole plus 2 half plus, well, I should X those off so I don't use them again, 2 quarter shapes. One whole shape plus 2 half shapes plus 2 quarter shapes is going to be 1, 2 and a half. It's going to be 2.5, or you can use the half symbol. And I have to find my unit. The unit they've given me is centimeters. And again, because this is a two-dimensional shape, I have to put the number 2 on top to let our audience or our readers know that we are calculating the surface area of a two-dimensional object. Let's look at this next one. Now this one has a lot of different shapes wedged out, so I really have to make sure that I X off all of my shapes so that I don't recount them again and get the wrong answer. Let's find the whole shapes. One whole shape plus 1, 2 half shapes. I'm just going to put a little symbol there. Plus 1, 2, 3, 4 quarter shapes. Or, if it helps you, write the word quarter, is equal to 1 plus 2 halves. 2 halves make a whole, so I have 1, 2, and 4 quarters makes 1. So I have 3. Now again, I have to look for my unit. My unit just says unit. 3 units squared. Now if at any time you zoned out during this video, make sure that you go back to check anything that you might have missed.